To sketch the graph of y equals cosecant x, we're going to recall that cosecant is the reciprocal of sine. So we're going to first of all sketch what the sine graph looks like. So if we draw in the key points, our quadrants, 0, pi over 2, pi, 3 pi over 2, and 2 pi. Let's first of all sketch the sine graph. And if you'll recall, sine is equal to 0 at 0, 1 at pi over 2, 0 at pi, negative 1 at 3 pi over 2, and 0 at 2 pi. So this is the graph y equals sine x. Okay, cosecant is the reciprocal of that graph. So wherever the sine graph has an x-intercept, wherever it's equal to 0, the reciprocal of 0 is undefined. So that means that the cosecant graph would have an asymptote at any place where the sine graph is equal to 0. So I'm going to draw those in first. And then to graph the cosecant graph, we're going to use our asymptotes as guidelines. If we go to a max value for the sine graph, for example, at pi over 2, sine is equal to 1. Cosecant would also be equal to 1 at that position because the reciprocal of 1 is 1. But on the cosecant graph, what's a max for sine would be a min for cosecant. So the cosecant graph will go the opposite direction. And here where the sine is equal to negative 1, cosecant will also be negative 1, but it will go the opposite direction. So how the period for the sine graph was equal to 2 pi, the period for the cosecant graph is also equal to 2 pi. These are not parabolas, but these parabola-looking shapes, one up and one down, makes one complete period for the cosecant graph.